volume of prisms. We've already learnt that the volume of a rectangular prism is length times width times height. And when you look at a rectangular prism, length, width, height, you'll see that that's not only multiplying the 3 dimensions, but it's finding the area of the cross-section of the front face and multiplying it by the height of that prism, also called the perpendicular height, which is the distance between the two identical faces. So the height of a prism is a very specific thing. It's different to, for example, the height of this trapezium. The height, or the perpendicular height of this prism, is the distance between its two identical trapezoid faces. So this can cause some confusion. Now this gives us the area of any prism. For volume of any prism, it's area times height. The area of the cross-sectional face, that's the same on the front and the back, and the height, which is the distance between those cross-sectional faces. So in this one, I actually haven't labelled the height, so let me just put that in 3 centimetres. So this is the height of this prism. I know this is the height of the trapezium, but this is the height of the prism. And the volume of this trapezoid prism is the area of the trapezium times the height. And there's 2 different ways we can tackle this. We can find the area separately and then use the volume formula. And that's actually a pretty good way of doing things when the shape itself has a height and our heights might get confused. So let's do that separately. Area of a trapezium is a plus b on 2 times height. 6 plus 9 on 2 times the height of the trapezium is 2. And so that's 15 divided by 2 times 2, which is 15 centimetres squared for the area of that trapezoid face. And then, of course, if it's 15 centimetres squared, going 1 centimetre back would give me 15 centimetres cubed. Going another centimetre back would give me 30 centimetres cubed in total, and another centimetre back, it's another layer of 15 cubes. So we can see that our volume, which is area times height, 15 times 3, will be 45 centimetres cubed. So that's how we'd find the volume, finding the area, and then using the area formula. Incidentally, some questions actually just give you the area. They'll point to this face and go 15 centimetres squared, and then it's just area times height. Any prism comes down to this formula. So the volume is area times height. Now what we can do when the shape has an area formula, which it will, is instead of area, underneath we can write the area formula for this specific shape, because this is the formula for every prism. For a circular prism or a cylinder, area is pi times the radius squared, and then we times it by the prism's height, and this is the volume formula for a cylinder, pi r squared h. But we can get it from the overall volume formula. Substitute in our values, pi times 3 squared times 7. Grab our calculator. Pi times 3 squared is 9 times 7. My volume is 197.9 centimetres cubed. So that's how we use the volume formula. If you remembered the cylinder volume formula, you could just start at that. But this lets you get the cylinder volume formula even if you don't remember it. Here's one which is a triangular prism. Now again, that's the height of the triangle, that's the height of the prism. We have to be really careful not to get those mixed up. But if we're doing this, volume is area times height. If you're at all likely to get it mixed up, do them separately. Area of the shape, then get the volume. But we can do it all together. area of a triangle is base times height divided by 2. And now we've got the problem that in this formula we'll have two different heights, and we can't say they're both little h here because that would be saying they're the same thing. So make the other height capital. That says I've got two heights and they're different. This is the triangle height, this is the prism height. Substitute in your values. 6 times 5 over 2 times 7. So 6 times 5 is 30, divided by 2 is 15. 15 times 7, 105. So the volume of this shape is 105. Now they didn't give us units, so we just say units cubed. So that's a couple of different ways of tackling the volume. Its volume is area times height for any prism. You can find the area separately and then do the volume formula, or you can combine it into one area volume formula. It is up to you. Don't get the heights of the shape and the heights of the prism mixed up. Now here's a question that's a tricky one that often turns up. A water tank with a 5 metre radius is being filled at a rate of 2,000 litres per minute with a fire hose. If the hose runs for 6 minutes, how much will the water level rise by? There's a physical situation and they didn't give you a diagram. So you'd draw your diagram and put in the information that you know, which is that I've got a 5 metre radius. I don't know anything about how high the water tank is, and I actually don't need to. Now, the problem here is that there's a bunch of bits of information, and we have to work out what information we need and how to get it. It said, how much will the water level rise by? So we're looking for this. We don't actually need to know where it was at. To start with, we can imagine it started from 0, so an empty tank, but it wouldn't matter if there was a whole bunch of water underneath it, because we're just going from where we started, how much did it go up by? And when you think about it, that's actually the height of this cylinder. The water level might only go up to here, and then we'd ignore that bit, and so we're actually finding the height of the cylindrical shape of water that ended up in the tank. Now we've got the radius, so we could find the area. We want the height, and that tells us we need the volume. We don't have the volume, but what we do have is the amount of water that went in. The amount of water that went in was 2,000 litres times 6, so 12,000 litres. Oops, yes, 12,000. That's not volume, that's capacity, but from capacity we can work out, or volume. 12,000 litres, well, it's 1,000 millilitres in a litre. Or you might remember that 1,000 litres is 1 cubic metre. So 12,000 litres is 12 metres cubed. So all of a sudden I've got the volume of water that went in. Now, we know the volume formula, so we start with it. I know the volume. Oh, let's get the area happening here. Volume is pi r squared times the height of the prism. We know the volume, it's 12. The area is pi times the radius squared. Oops, 25, because that's 5 squared, I just cheated, times the height. Now, here's a trick for you, because we need to find the height. And so we're going to do the volume divided by the area. But you know how your calculator keeps on giving you pi in your answer? So when I do pi times 25, it just says, well, that's 25 times pi. The reason it's useful to do that is that that's actually an exact answer. You don't need to go rounding. If I got this, I'd have to go divide by 78.5398 to get an accurate answer. we can divide both sides by the area so that the height is 12 divided by pi times 25. And that will get us just the height of the water, 12 divided by 25 times pi, and the water went up by 0.15278 meters. Height equals 0.152, let's round 8 meters. Now that's not a very friendly answer. We might prefer it in centimeters, and it was a word question, so a word answer. The water rose by, now, meters to centimeters times by 100, 15.3 centimeters. So it's a problem-solving question where we know the volume and the area, and we have to find the height.